A good day to everyone who's watching. In our lesson today, we're going to talk about relations, mappings, and functions. So we can go through the definitions there. A relation is an expression that indicates connection between one or more sets. A mapping is a diagrammatic representation of the relations. A papygram is a diagrammatic representation of relation within members in one set. So we are going to first look at these relations, how they are connected to the papygrams, and then there is also arrow diagrams. We are going to look at them also together with the papygrams and mappings, and together with the relations. So example 1. Set A, which is 5, 6, 3, 9, 12, 10, draw a papygram to represent the relation, a multiple of. So these relations here, just like the way the word is in English, it shows a connection between, it can be people, for example, my dad, the relationship which is there, or my brother and sister, the relationship which is there is sibling. So that is the relationship. So I draw my circle there. I'm going to feed in these elements here. That is the 5, 3, 6, that is 9, then 12. There is also 10 there. Now I begin to draw arrows to show this relation here. Multiple of 3 is a multiple of what? 6 is a multiple of what? 12 is a multiple of what? And any other element there. So these elements, they are multiples of themselves. 6 is a multiple of 6. 12 is a multiple of 9 is a multiple of 10 is a multiple of 10. 5 is a multiple of 5. Then I'm going to include arrows on them. Then now I check the 6 is a multiple of 3. I draw that arrow there. 6 is a multiple of 3, so I need to show the direction of the arrow to fulfill the relation. So 6 is a multiple of 3 right there. I go to 12. 12 is a multiple of 3 there. 12 is a multiple of 6 there. 9 is a multiple of 3 there. Then there is also 10 is a multiple of 5. I do that there. So this is what we call a papygram. So example 2, given set B as 2, 4, 5, 6, 7, draw a papygram to show the relation, the factor of. So the same way like I did example 1, it's the same way that I'm going to do this. I need to represent my elements there. This is 5, then 7. Put them in a circle. Now, not forgetting that every element in set B is a factor of itself. So what I do, I'm going to draw circles around them, then put the arrows. This means 5 is a factor of 5. So after doing that, every element is a factor of itself. Then I look for the rest. 2 is a factor of 6. 2 is also a factor of 4. Then nothing I can add on so much. 5 is a factor of 5 alone, and that is a factor of 7 is a factor of 7 alone. Now example 3, set A is equal to 1, 2, 3, 4, and set B 1, 4, 9, 16. Draw an arrow diagram to show the relation B is a square of A. Now here, this is going to lead us to what we call the range and the domain. Set A, we're going to be referring it as a domain, and then set B shall always be referring it to as the range. So I've drawn my sets there in that format. So they have said the relation should be B is a square of A. When you square 1, you get 1. When you square 2, you get 4. When you square 3, you get 9. When you square 4, you get 16. So 16 is the square of 4. 9 is the square of 3. 4 is the square of 2. 1 is the square of 1. To take us back to the relation, B is a square of A. So these arrows, we need to indicate them there. And then we shall always be calling set A as the domain. And then we shall always be calling set B as the range. Then there is going to always be what we call a mapping or a function that will be sending elements from set A to set B. And then elements in the domain, we shall always be calling them objects. And then those ones in the range are the what? Are the images. So the function or the mapping will be enabling us to send these objects to corresponding images the other side. Both of them, they are going to be sets, and then diagrammatically this is just an arrow diagram. We can represent the range and the domain on an arrow diagram, but writing a range and the domain, we write them as sets. So kinds of mappings, we have there 1 to 1, then many to 1, then 1 to many kind of mappings. 1 to 1 is that one element in the domain here, that is the first set there, is being mapped onto one image that side. One element mapping onto one image, one object mapping onto one image, all throughout. So that is why we call it 1 to 1 mapping. Then many to 1, we have more than one element in the domain here being mapped onto only one element. So here there are 3 here, 3 objects, they are being mapped onto one image. That is the many to 1. Then lastly we have 1 to many. One element is being mapped onto more than one image in the range. So that is the range. And then this one here is the domain. That is why we call it 1 to many. Many to 1. 1 to 1. Now, in some textbooks, they like so much adding there many to many, but I've never seen a mapping that can give me many to many mappings, or that can bring about the diagram to have so many elements here being mapped onto so many images the other side. So our example for there, draw an arrow diagram to illustrate the relation. B is a cube of A, where set A is this, and set B is that one there. So I've drawn my sets A and B right there. Then now I include the arrows to make a complete arrow diagram there, showing that our 1 is the tube of 1, 8 is the tube of 2, 27 the tube of 3, 64 is the tube of 4, and 125 is the tube of 5. To go back to our relation that B is a tube of A. Example 5, state the relation in the figure below. We need to look at the elements in that figure there. Then you find out what really the relationship is. So when I look at the arrow is from 17 to 13, then 13 to 9, then 9 towards 5. So when I try to get the relationship here, or when I try to subtract 13 minus 17 minus 13, that is a 4. So the difference here, 13 and 9 is also 4. Difference there is also a 4. So that means that 9 is greater than 5 by 4. 13 is greater than 9 by 4. 17 is greater than 9 by 4. So the relation is greater than by 4. So we can talk about the domain and range. We had talked about this earlier on in the first examples there. These are two sets. One contains the objects and another one contains the images. So in those first examples, we have been given the two, and then we needed to represent them on an arrow diagram. We have been given one of them to represent on a PAPYGRAM. So now we are going to do examples where one has been given and we are looking for another set, but there is going to be a mapping that is going to be helping us to get or to generate the images of the objects being given, or the images or the objects when the images have been given. So the mapping can be represented like that. It can also be represented as f of x is equal to x squared plus 1. That one can also be another representation of a mapping or a function. We say the domain contains objects, and then the range is the one that contains the images. We're going to generate or get the images using the mapping. So our mapping that has been given is x, sending elements of x to row x squared plus 1. Now every element here, we're going to take it to be a value of x. Then we feed the values of x in there and get the result. So the result is which is going to be as the images of each value that we feed in there. So our domain is there, and then the mapping. Now I'm going to get the 1. So 1, object 1, I put it in the mapping, that is 1 squared plus 1. And then this one here, I get the 2. Then I go to the next, is a 3. I feed it there, 3 squared plus 1. This one gives me 9 plus 1, which is 10. Then 5, I substitute it there, 5 squared plus 1. So 5 squared is 25 plus 1, that's going to be 26. Then 7 I feed it there, 7 squared plus 1. This one is going to be 7 squared is 49 plus 1, which is 50. Therefore, the range is the first image there was a 2, then 10, then 26, then 50. So we need to write the range as a set, because even the domain was given there as a set, and both of them must be sets. Most people just like to draw arrow diagrams. Draws the domain, then the range there, feeds the 1, 3, 5, 7, then 2, 10, 26, and 50. Then it does the arrow diagram. So that one there is just an arrow diagram. Yes, it doesn't necessarily mean that you have got the range. Just get the range as a set. Then if they ask for the arrow diagram, then that's when you draw the arrow diagram. So example 2, find the range for the mapping f of x is equal to x squared when the domain is -1, 0, 1. Our mapping f of x is equal to x squared. Now I need to get, remember I said these are all values of x, every element there. So I need to get the f of -1. Substituting here, this is -1 squared. When I square it, I'm going to get a +1. Then I go on to get the f of 0. That is going to be 0 squared, which gives me 0. Then I get the f of 1. That's going to be 1 squared to get 1. Therefore, the range is, the first image there is 1, and I also have 1 here. So I'm going to write one of them, and that's going to be my range. Why am I writing this like here? One because I'm having 2 images which are the same, and I'm writing just one of them there, because when I try to draw the arrow diagram there, domain and range, the -1 is mapped onto -1, and so is the 1. Then the 0 is mapped onto the 0 there. You can see that this one shows a kind of mapping which is many to 1. So if you include another element here, the mapping you'll be seeing, the kind of mapping you'll be seeing 1 to 1. Okay, and that one's not good. That is, if you had 1 there, 0, 1, then -1, 0, 1 here, and then you do this. This kind of mapping here is now 1 to 1, but it should be many to 1. So that is why you need to put, if the elements they are the same, the images, you need to write one of them in the range. So example 3 there, if the mapping is 2x minus 3, find the missing values in the range and the domain. So we have our displays of the domain and the range there. The domain is always the values of x. When you feed them here, you'll be able to get the images there. For example, if you try to put 2 in there, that's going to be 2 times 2 minus 3. This one here is a 4 minus 3, and then you get the answer as a 1, which is that. So when I want to find my value of a, when I feed in the 3 in there, I should be able to get my value of a. So I've said the mapping is that one there. Then when I try to feed in here, the 3 minus the 3 should give me my image, which is A. When I multiply here, be having a 6 minus 3 to give me the A. And when now I subtract this side, this is going to be the A as what? As a 3. Then I go to the same case here. When I get my 2 into 4 minus the 3 should give me the B. When I multiply here, that's going to be 8 minus 3 to give me the B. When I subtract, I'll be having my value of B as a 5. So here, lastly, to find the value of C, when I get my C, tap it there or substitute it there, I should be able to get 9. So this is 2 into the C minus 3 should be able to get me a 9. When I multiply here, this is going to be 2C. This one here, when I take it the other side, it's going to become a positive. So that's going to be 9 plus a 3. When I add this side, this one here gives me a 12. Then this one here is a 2C. Then I divide now both sides by 2 to get the value of C as a 6. Example 4, given the domain, that one there, write down the range for g of x is equal to x plus 2. So here, it's all about substitution. Where there is a value of x, you substitute the elements in the domain. It's just all about that. So my function or the mapping is x plus 2. Then I need to get g of 2 there. So substitute where there is x, I'm going to put a 2. So that's going to be 2 plus 2. And then I get a 4. I go for g of 3 there. G of 3, I substitute 3 plus 2. Then when I add, I get a 5. Then I go for g of 4. When I substitute 4 plus 2, then I get the value there as 6. I get the g of 5. When I substitute there, that's going to be 5 plus 2. When I add, I get 7. Therefore, the range is the first element there, the first image there was a 4, 5, 6, then 7. As simple as that.